Let's look at a short proof that introduces some of the basic rules of natural deduction we've already looked at. So we're going to prove that the following argument is valid. Premise 1 is if B, then A and not C. Premise 2 is B and D. And from that, we can conclude not C and D, or if E, then F. I've already set up the basic structure of the proof. So we're going to have some number of lines of the proof. And the first two lines will be the premises. Those serve as our assumptions. And we're going to assume those are true and show that if they're true, using the rules we've discussed, the conclusion will follow from them. So when I look at this, I need to look at the main connectives and think, how can I break down these sentences in a way that might allow me to build up this complex sentence at the end of the proof? So it's helpful to look forward towards the conclusion and consider how you might build to that complex sentence in the conclusion with the sentences you have as your initial assumptions. So some things to notice. The main connective of the conclusion is a disjunction. I know there's a rule for disjunction introduction, so that might be the rule that I use towards the end of the proof. Another thing I should notice is that the sentence letters A and B appear in these premises, but they don't appear at all in the conclusion. So it's likely that I'm going to have to break down those first two sentences and then put sentences back together in a way that doesn't include A or B. So I will start with premise 2. That one is simple. Its main connective is conjunction. And we know that we have a simple conjunction elimination rule. So conjunction elimination, we apply that to 2. We can get B. And I'm going to leave just B there for the moment. And part of the reason I wanted to get B out of that conjunction is I also noticed that it's the antecedent of my first premise, which has a conditional as its main connective. When you have the antecedent of a conditional and a whole conditional, you can apply conditional elimination. So if we apply that to the premise in step 1, and we use the antecedent in line 3, that allows us to run conjunction elimination. And that gives us the consequent of the conditional. So the consequent there is A and not C. Now here again, I have another conjunction. I know I'm not going to use A, so I don't need to break that out. But not C does appear in my conclusion, so I will likely need that. So I can introduce not C, and again that's by conjunction elimination, this time on line 4. So we can apply this to a line derived from previous lines. Now I also know that not C and D is one of the disjuncts in my conclusion. And I can get D from applying conjunction elimination to premise 2. So I'll do that now. Conjunction elimination applied to line 2. Now I want to get not C and D. And I can do so using the rule for conjunction introduction by combining lines 5 and 6. So that gives me not C and D. So conjunction introduction says if we see a sentence on one line and a sentence on another, we can conjoin them. And then finally, the main connective here is a disjunction. Well, we have a rule for disjunction introduction. And that allows us to introduce any other disjunct. So we can have not C and D as one of our disjuncts, and then we can add any other sentence as our other disjunct. In this case, E, if E, then F. And we got that line by applying the disjunction introduction rule to line 7. And that concludes our simple proof. So what we've shown is that if we assume these two premises, we can arrive at this conclusion using the rules of natural deduction.